1700 years after Pythagoras, 1800 years after Pythagoras, finding again this pattern keeps repeating, that ratio keeps repeating within it. Again, ideal body shape comes in with it. Is that pretty well it? Okay. That's the non-mathematician's explanation.
No, that's, I don't know, well, I know there's something that has to do with finding the roots of a special quadratic equation, but I don't remember what equation it is. So when we get to the quadratic formulas and equations, I'll look that up and see what it is. But it's an irrational number, just like pi, and so the number never terminates, never repeats itself, just goes on forever and ever and ever. But yeah, I guess it's just basically to take the ratio of any number in the Fibonacci sequence to take the ratio of a number to the number before it. And I actually was surprised to hear this, because I didn't know that, but it sounds like it will always be. I've heard it called phi is the name of it.
Yeah. Again, they would use it. They would for certain special numbers. But that was, if you look at classic architecture throughout the Western world, that proportion is always there. All right, the things we consider beautiful are always in that format. I'm not sure about 8.5 by 11 sheet of paper, but it's going to come pretty close to it. Now, if you take a rectangle, that's you take a rectangle that follows those proportions, all right, and 1.6. If you cut a square out of it, that's 1, 1, 1 all the way around. The leftover rectangle, and I'm not drawing a scale, the leftover rectangle will be 1 to 1.6. You cut a square out of that, the leftover rectangle, 1 to 1.6. No matter how many times you divide it, it will always keep that same sense of proportion within there. And that's why it became, for Pythagoras and for his followers, and then later Greek architecture became like one of the prime things. The temple to Athena Nike, is laid out this way. The Parthenon is laid out this way. All of the major temples, even the Romans, for their major temples, picked up the same proportion to work within it. And just it's one of those quirky little numbers.
That's driving me a little crazy, because I remember, and I want to get on mathy here, I remember the quadratic equation that was set up was based on subdividing the rectangle like that. Right. And I cannot think of how the equation was set up, and I'm going to look that up. But when you use the quadratic formula, it ends up being an irrational answer, and it is phi, the golden ratio. So I just have to look that up and see what we take from there and what it is we're actually trying to solve. But you can show mathematically that that's where it comes from. We'll get to that in the next chapter.
You always get to things in the next chapter.
We really will.
That's what I always tell my guys. Like the first exam, we'll get to.
Well, something else you mentioned about, it's only relatively recently that mathematicians and scientists and anybody really was okay with zero and negative numbers. And those of you that are doing the Great Books option, when you read his it's an appendix, actually, geometry, an appendix to the discourse on reason. I have to look up the whole title. But in this appendix, which is called geometry, he talks about finding roots, and he talks about finding false zeros, false roots. Those are just numbers that are negative. And so even back in Descartes' time, which is only like 4 or 5 centuries ago, they still were not very happy. They didn't seem like something useful at that point. So it is really, it's pretty recent that we've accepted and even had any kind of understanding of zero.
And for the Western world, our math is still heavily influenced by Greek mathematics. And for the Greeks, finding area or volume negative for Pythagoras and for the earlier Greek mathematicians, but for Pythagoras and his students, if you came up with a quote-unquote negative number, that meant your equation was messed up. All right, there's something wrong with your premise. You couldn't have it. All right, it didn't work that way. I mean, it didn't work. Zero didn't work. Archimedes, the man who screamed Eureka, because he figured out a way of using displacement to show how pure gold was for the king's crown. He rejected the whole concept of zero, even when he was working with areas of parabolas and things that they worked with. It's still, for a lot of cultures, zero is just, it's out there. People who can work with it, who can manipulate numbers, again, that's magic for a lot of people in the world even today. Writing is magic for many cultures. Ibn Ezra talking about visiting the Norse. And some of you have seen the movie The 13th Warrior, which is taken off. And that's why one of the Norsemen asked him, because he's educated, he said, draw me pictures that mean words. You know, draw me these things. I mean, for them, that was magic that he could write out. You know, there is but one God, and Allah is his prophet. You know, to them, that was, you know, it was kind of spooky that people could do that. I mean, that's, and for a lot of cultures, you know, a lot of developing cultures today, but still, writing is kind of out there. And negative numbers, no, which is why they have problems with bank accounts.
If you want to go backwards, you have to have negative numbers, right?
But for most cultures, why would you go backwards?
Well,
You can't have -5 bananas.
Being in debt,
Yeah.
like banks.
Yeah, for banks. Well, bank, yeah.
Just throwing it out there. But
Yeah.
They are there.
My checkbook has a negative balance. A very abstract math sort of way.
I think we're in the same boat there.
Well, and Fibonacci actually brings 0 into Western math, and this becomes important. But at Fibonacci's time, banks were still using abacuses. Abacuses. Abaci. However the plural is. Abacuses. And the problem with the abacus is you didn't have decimal points. And a lot of banks wouldn't allow that. When Fibonacci and others started bringing Arabic-style math in, you could come up with decimal points. Well, a lot of banks and a lot of cultures, they wouldn't allow that. They said, no, we're not going to do that. Until they said, wait a minute, with this decimal point, you can actually make more money. In which case, all of the banking systems said, we're going to Arabic numerals. We're done. Forget the abacus, we're going to Arabic numerals because decimal points now mean something. And so it kind of changed our way of thinking about mathematics and about commerce and opened up trade.
You guys remember in Office Space where the guy who wrote the program to capture like a penny from
the Superman.
Yeah.
Yeah.
That makes me think of that.
Pennies on the
In real
dollar.
life, it never really works.
You must have
Maybe
the
you
test
call it.
It seemed like such a good idea.
Yeah, it seemed like such a good idea at the time. Well, that's why and the Westerners rejected it until they should be shown you'll make money if you go to this new math program. You'll make money. I still like my abacus. Simply because it's just a fun thing to play with. Turn it upside down, put your hourly man on it, roll it all. When I was a kid. All right, last week. Anything you want to ask me that has nothing to do with the program or with the presentation?
Do you miss Texas?
Actually, I do not miss the heat and dry for right now. I'm going to enjoy this rain and cool while I can.
How far away did you live from Austin? Do you live from Austin?
I live 90 miles
The Bat Bridge is way cool.
from Austin. Yeah.
Which way?
East, southeast. I have to kind of draw a line.
I didn't know of the Bastrop fire. The reason I was getting to is I worked at Sherwood Forest Fair,
Right.
which is just north of Bastrop, and I was wondering if that got burned down there.
No, it's on the east side of 290.
Yeah.
Everything there is on the east side of 290. Everything on there is the west side. Is the west side of 290 and near Highway 21. And it is jumped through there. Right now, the count is 1,500 homes just in that fire. And we've had several other fires throughout the region. The closest one to me is the Tri-County fire. It's 30 miles away from mine. And occasionally it smells like a giant campfire. Still going on. The Bastrop fire is now mostly contained, but it was, at this point, this was still 3 distinct fires. You can see 2 of the distinctive smoke plumes. The other one was on the back side. By the middle, by last Wednesday, it became one solid fire. One solid fire line. It is 80% contained now, which means it's not spreading any further. It's still burning in the interior. Then there's still people who can't, almost 2 weeks later, still not clear to go back home. Again, y'all can figure out the math. It's a little bit, you can probably do it geometrically, figuring this out. I know you can do it as a trig problem.
Similar triangles might work.
Yeah. So you'll just have to work with kind of points of scale to work with that. Again, it's 30 miles. Bastrop is 30 miles from downtown Austin from this shot. And you can go look up the size of the buildings in Austin, the height of the towers in there, and use that as kind of a scale to start setting up and figuring what it is, and then coming up with what the tall height there of the smoke plume is.
Is it the golden ratio? That would be ridiculous.
Don't forget to calculate the curvature of the Earth.
Yeah. I didn't say this was going to be an easy problem. I didn't say it was going to be easy. And the curvature, I honestly, everything I've ever done when I started getting into abstract math, everything, the golden ratio comes up quite a lot. And
Are you saying I'm right?
really, it comes up in some really unexpected places.
It's not going to help me win the lotto, I don't care. Well, now he's thinking.
Well, that's my algorithm, see what comes up next. I think it's an Excel spreadsheet that looks at the Texas lottery, which numbers have come up most often in these columns, and it still hasn't helped me any.
Probability, but I don't think that helps you.
Because you're not using that golden number.
I probably plug that in when I get home.
A math professor, I think she was in Texas who won the lottery 3 times.
Yes, there is a math professor in Texas who has won the lottery 3 times, and she is under investigation. They haven't been able to make anything stick. She never worked with the lottery commission, but any lottery, Colorado's good lottery.
Yeah.
All of them have an algorithm they use to make sure, because if you use a random number generator to figure out which scratch cards will be winners, you can actually have 6 winners all come together right in a row. And theoretically have one store fill all 6 winners. So they have algorithms set up to make sure that they're spread out and
Oh, I
there's
don't like
distributions.
They always get back like 1 and 3 or 1 and 4.
You've been going to come and go all this time.
Yeah, so they
Or actually,
figure
you
out,
tell
so
people
they're
before you
trying
buy
to figure
1
out,
and you buy
they
3
think
after them.
they're trying to figure out if she broke the Texas Lottery Commission's algorithm. So they're,
But
because
how
it's,
could that couldn't be illegal, I wouldn't think.
well,
It's like counting cards.
Once
in
again,
Vegas.
you know,
It's not illegal, but it's very looked down upon. They look at it as a lot of money.
it's,
Oh, you just disillusioned me. I really thought it was a random number generator.
Does she offer classes in winning the lottery?
Why would she share her
Online.
online.
Online, I'm looking for it.
Probably like write a book about the wrong answers.
Think good rainy thoughts and send it my direction. This year we're 15 inches below where we should be.
You're out of August though, the worst is over.
Not for us.
Holding Colorado.
Yeah, only in Colorado. Yeah. Well, we're 15 inches behind so far this year. We were 14 inches behind last year. We were 12 inches behind the year before that, and 10 inches behind the year before that. So we got a long
You
ways
do
to
the
go.
math.
And there is no golden ratio. There's really nothing golden.
Thank you.
Thank you.
So, before you guys take off, I would, actually at this point, if you do want to leave, I'd say you can, and once I'm done talking, which I will be done at some moment. But if you want to hang out and talk to Dr. Allison about anything or ask him any anthropology questions, I imagine he's open to that. Or if you want to ask me any math questions, you're welcome to. But of course, after that, I'm not, who knows. But I do have the remainder of these separated for whoever would like one. This is Euclid. I do want to warn you that you're going to start reading what he actually wrote, or at least a translation of what he wrote, or the group of whoever that would work with him. And it's very difficult reading. I read this myself, and being that I do not use the same vocabulary as they did back when Euclid wrote this one, was it? It's sometime between 347 BC and 287 BC. Very different vocabulary, very different way of thinking about mathematics. So don't expect yourself to understand all the things he writes. Read it through, get a sense of what he's trying to talk about, and don't be frustrated if you don't get it. As we go into readings that get more contemporary, they're going to be easier to read. So just want to warn you, don't panic when you start reading it. And there is information about him and the translator in here, which will help you understand some of what he's doing.
Not for the grade books?
This is the grade books, yeah. So I'll hand out. These are not stapled because our copier does not have staples anymore. So I'm done talking now.
You're still recording?
Yeah, that's fine.
You don't drive today.
You're muted.
Sorry for that.
Oh, no.